This video is a description of our application of DAQ2GO to a gas chromatography application. We built a gas chromatograph having 4 columns and 6 detectors that required automation and remote control. And we needed a complete data system to control the device and take the data. We chose to use DAQ2GO to do this job. Well, what is it and how does it work? Well, DAQ2GO is a combination of software and electronics put together, and it's actually used specifically for making complete and functional measurement systems and control systems just from a collection of sensor signals and hardware elements. And it was designed to avoid the need for special programming or for extra electrical engineering. It basically is an environment that incorporates multifunctional instrument-grade I/O electronics with software functionality, all based in Excel. There's software there to take, store, and treat data in a whole bunch of ways, and it's really configured for instrumentation and process control applications, as well as robotics and custom devices. It's easy to modify, use, and mix and match the pieces. Now, in traditional GC, you've got a handful of things. You need to set up the experiment. You have to define the analysis time, temperature programs, flow programs, how you want it to look, and if you want to have automation and the details of that. You also need some kind of user interface, strip chart recording, and so forth. Then you actually have to take the data, store it, and then treat it afterwards, and finally prepare a report and archive the results. In DAQ2GO, there are actually user worksheets to do most of those jobs. There's a user interface worksheet, a control worksheet, an appearance worksheet, some sample queue worksheet, and quite a lot of workbooks, whole workbooks on post-processing of the data. The first worksheet in DAQ2GO is basically a worksheet in Excel with a control form on top of it. The control form actually has little buttons for initializing the hardware, taking data, stopping the experiment, reconfigure the hardware if you need to, and then export the results. Down at the bottom you'll notice tabs, which you expect in Excel, and these tabs all have very neat functions. One of the first ones to look at is the worksheet called the control worksheet, and in it you can do temperature programming, you can control timing of valves and all of that sort of thing. There's another control worksheet which is just for how the thing appears. If you add extra tabs and the like, you can name them and color them and define their characteristics. So let's start the run. Just click on Start the Scan. The minute you do, it immediately does real-time strip charting, in our case, all 6 detectors at once. And down at the bottom, you'll see those little tabs. We set them up for all of our various analytes, so we could flip through them and look at them while the runs were taking place to see if the run was going to be any good. After a while, we, in immediate mode, just stop the run with the DAQ control. This, of course, could be done in an automated way. And then we were at the point of looking at the data and decided to export it and store it, and then subsequently go to the next parts. So we export the data. It exports as an Excel sheet with all of the experimental information on it. Now at this point you have a crossroads of looking at the data qualitatively or quantitatively. And there are tools just for that purpose. Qualitative tools and quantitative tools, and they do all kinds of things. Work with multidimensional arrays, do calibration and quantitation. Here's a list of some of them. There's also things like baseline changing and peak detection and calibration and all that, and here are some of the features it can do. Here's the calibration tool, but you can see all of that extra stuff on the website at DAQ2GO. These are the requirements, and it met all the requirements at once. There's the site.